chemistry students. What we're doing today is we're learning about Hess's Law. We're going to do two things for Hess's Law. We're going to solve problems relating to energy changes, so we're going to use it in problems. And we're also going to conduct an inquiry, not in this lesson, but actually in class. We'll do a lesson where you just go over and we actually do different reactions. We use Hess's Law to solve problems. Well, what is Hess's Law? Well, basically what Hess's Law is there's two methods to it. Before I describe it, excuse me here. There's a long way and a short way. We're going to talk about the long way first. So, the definition of Hess's Law is that the value of any unknown enthalpy. So we don't know an enthalpy for a reaction. Well, it can be written in steps equal to the sum of the value of delta H for each individual steps. Well, what does that mean? You should have been confused by that statement. All it means is that chemical equations and their enthalpies can be added together and manipulated algebraically. So if you have a value of delta H and you want to multiply the whole equation by 2, you multiply by all the coefficients by 2, you'd multiply the enthalpies by 2. So if you want to take the whole equation and divide every single coefficient by half, you can do that as long as you divide the enthalpies by half. If you want to add two different equations together, you can do that as well. And that's pretty much what the Hess's Law is. Let me show you an example. We're going to actually go through two examples. This example here, we have carbon solid plus half O2 equals carbon monoxide. Now that's difficult to do. We can't do that in an experiment. We can't determine it. There's no experiment that we can design to do it. So what we do is we find other experiments that we know the delta H for, and we add them together to equal this equation that we don't know. So let's talk about two equations that we do know. Here, let me just clean this up. So if we look here, this is the top equation is one that we don't know from the previous page, but we do know these two experiments experimentally below here. And if you take a look at this 1 and 2 right here, so this 1, this 2 here, that does not mean molar enthalpy. It is not molar enthalpy. What it is just telling you that it's equation number 1 and number 2. Sometimes I like to put little subscripts there, 1 and 2, but I also like to put it in the front here. Now what we're going to do with these two equations, equation 1 and equation 2, you can see that we know the enthalpy for both of them. So we're going to try to add them together to equal our target reaction up here. And the way that you do this, it's just a simple thought process, and you say, okay, my first equation has carbon solid in it. It also has O2 in it. And if you take a look, our target reaction also has carbon solid and also O2. And you'll notice that both of them are reactants. Because they're both reactants, that means we want to just leave them as reactants. And we're going to not do anything with this first equation because it's where it's supposed to be. These are reactants. It's reactants in my target. Leave it alone. Look at the next reaction. If we look at it, we can see that carbon monoxide is actually a reactant in it. But in my target reaction, it's a product. It's on the wrong side, guys. What are you going to do? Well, what you need to do is you need to get it on the right side. So for equation 2, we are going to multiply everything by -1. And what we mean by that is we're going to flip the reactants with my products. We're going to get it on the right side, okay? And so we're going to reverse number 2, and we also reverse the sign of number 2. So we flip it, everything here, and we multiply the delta H by -1. So a negative times a negative, we'll get a 283.5 kilojoules. That's positive for equation number 2. Let me show you what it looks like after I flip them. Okay, so now what I've done is down here we reverse the second equation. This is still my second equation. This is the first one. And all we've done is we've just flipped it and we've changed the sign. Now what we're going to try and do is we're going to add them together. And the reason we're going to add them together is we should end up, you always add the equations together first of all, guys. And if you add them together, hopefully, let's just cross our fingers that these guys will turn into our target of reaction right at the top. Now let me show you what happens when I add them together. So I'm going to take all three of these guys, they're all going to be reactants now, and all these guys are all going to be products. Should look like this. So you can see here that I've added both equations together. I have all my reactants on one side, all one products. I just added my delta H's together and I get this value right here. Now the thing is that this is not equal to our target reaction because our target was carbon plus half O2 equals CO. But if you take a look at this, let's look at it a little bit closer. I have one CO2 as a reactant. I have one CO2 as a product. Therefore, just like math, whatever you do to one side, you can do to the other. So I'm going to subtract one CO2 from each side. That completely eliminates the CO2, so it looks a little bit more like our target. But we were supposed to have half O2, you remember, as a reactant, and no O2 as a product. Well, what we can do is we can subtract half O2s from both sides as well. And if we look here, this is 1 O2 minus half O2. This will be your target reaction when we do this. This will be 1/2 O2 equals carbon monoxide gas. So when we added them together, we actually figured it out and we got our target reaction. And we found our enthalpy that was unknown. That is very important that we're able to do that. So again, just to go through the steps, we rearranged everything to kind of look like, so we rearranged the sub-equations that we have here, equation 1 and 2, to look like our target reaction. Then we added them together, and the right things canceled out, and it works. These are all going to be cookie-cutter type questions where you rearrange, you add them together, the right things cancel out, and you get the right answer. That's how it works, these questions. Let's look at one more example. Okay, our next example here is we want to determine the enthalpy for this equation here. We don't know what it is. It has a little subscript here. Again, it doesn't mean molar enthalpy. It's just a Hess's Law thing. We have an H2O liquid. We want to figure out the amount of energy it takes to require to turn it to H2O gas. Now, so the question will always give us these givens. They'll always give you given equations. So we know the first one is H2O gas plus half O2 equals H2O gas. So H2 gas plus half O2 gas equals H2O gas. Gives us a known enthalpy. The second equation is H2 gas plus half O2 gas equals H2O liquid. It also gives us the enthalpy. So what we want to do is we want to rearrange these to look like our target reaction. Okay, remember, if we need to, we can take our equation 1, we can multiply it by 2, we can multiply it by a half, we can multiply it by negative. If you multiply by negative, that means you're going to flip it. Now let's take a look at where we have H2O gas here. I just did a quick scan, and I saw that these guys are both in my target equation and my target, the one I want, and my given equation. So they're both products, so I'm going to leave that alone because that looks normal. Then I do a quick scan of the second equation. I see that H2O liquid is there. It's also here, but it's on the wrong side. So again, what we're going to do is we're going to flip equation number 2. So we're going to multiply it by -1. The reactants and products will flip, and that's it. Now, again, we're not going to multiply it by 2. I don't think we need to do that. If you did, you'd have to multiply the enthalpy by 2. Instead, we're just going to multiply it by -1. So let's see what happens when we flip it. So this is what it looks like when we flip it. And equation number 1 is just the same. And equation number 2, you flip it, but you change the enthalpy value. Now what you're going to do is you're going to add all the reactants together and all the products. If you want to do this a little bit faster, you can already start canceling out these guys. This says half O2 on one side, on the reactant side. It will cancel out with this half O2 on the product side. There's an H2 on the reactant side. There's an H2 on the product side. So you don't have to show it like I added it up. And the only thing that you have left is H2O liquid and H2O gas. So that is indeed exactly what our target reaction is. It was H2O liquid to H2O gas, and that's all we have. We add them together, and what we get is H2O liquid, H2O gas, and our enthalpies, we just add them together. So those are some examples of what you can do to solve Hess's Law. We'll do a few more examples in class to help you make sure you understand it, but that's it. Enjoy the video. Hope you watch this tonight and are prepared for class tomorrow.